G'day, I'm Glenn Morris from the Smart Energy Lab, and I'm here today at CENIC with Pedro. He's the European manager for Arctech Solar, and that's a pretty big deal. Thank you for taking the interview with me.
Not a problem.
Look, I've had a long association with Arctech. I really love the technology. Tell me a bit about what you've developed.
Right, so before I took on this role, I used to be the global director of engineering, so I'm really familiar with the fundamentals, all the physics, all the science and engineering associated with the tracker. Arctech a few years ago kind of changed the paradigm and moved on from traditional flexible trackers to what we call the rigid trackers. Okay, so it's important to note that rigid trackers are the best pairing for the new generation of PV modules that actually grew in size.
Right.
And we can go over that if you want.
They have grown so tremendously. I've
Yes.
seen 720 watt modules here.
Right. So those are still the modules of the future.
Yes.
Today, people are installing, in the range of 585 to 660.
Yes.
But those modules are already pretty big.
Yes.
Bear in mind that, in a couple of years, we went from a, 2 by 1
Yes.
meter footprint to 2.4 by 1.3.
Yes.
That's a 56% increase in area.
Yes.
So that area collecting winds has a huge increase in terms of dynamic pressure.
Yes.
And that's a very big challenge for trackers.
Yes.
So we had to do something about it.
It's amazing how complex it is to me. Like, my simple understanding was trackers face the sun, turn east to west throughout the day. But you just identified that it's actually things like wind load
Right.
and the amount of energy that you can produce. And you have to protect yourself from those high wind events, but not lose too much production.
Right.
So it's a juggling act, isn't it?
It is. And, it's not only protecting our product only, it's protecting the whole installation. Because you bear in mind that the trackers are the components that are connecting the modules, which is the active generator of electricity, all the way to the foundation that is anchored to the ground, right? So, it's not good enough to make a sturdy tracker that when the wind comes, the tracker will stay put. We need to think at the system level so the panels don't suffer, the electrical BOS doesn't suffer as well. So the whole asset is protected.
I was amazed that with the 1P trackers, they have quite a small support area, but it's because the trackers absorb energy rather than, I think it's a bit like Tai Chi. You don't sort of go like this, you go like this and,
Right.
and give a little.
Rigid trackers specifically, like the ones you are familiar with.
Skyline 1, SkySmart 1, the SkySmart 2.
Right, so specifically the twos,
Yes.
the ones were still in the traditional flexible trackers. The twos were when we transitioned over to the rigid trackers, which are the only trackers that we've been doing so far now. And those trackers, the ability they have is to stow flat.
Yes.
And that's the game changer. Because with such large modules, if you still face the wind like this, the pressure onto the module surface is so high that that module will suffer delamination, micro cracks that you will not even notice. So all of a sudden, you will go to your SCADA, you will monitor your performance, and you see, string 39 is at like 50%, and that string over there is at like a 30%, and you don't understand why. So you have to go with a multimeter, measuring module by module to see where the problem is coming from.
Yes.
And that happens because the modules are so large, and with the old trackers, you're still facing the winds.
Yes.
So you say, but why do we have to face the wind? Well, because traditional flexible trackers, if you don't stow at a steep tilt, they just fly away.
Oh.
As terrible as that. So you either put the trackers in a steep position so they are stable,
Yes.
or the route we took, you rigidify the tracker so much that and allow finally the tracker to stow horizontal, which is what the Skyline 2 and SkySmart 2 are doing right now.
Which gives you a much higher stow speed too, doesn't it?
Yes. And that's a key aspect to increase your energy generation.
Yes.
So I typically talk about safety first. So, you invested in your asset, you want to protect your assets, but it's nice to have in an industry with growing panels, when everybody lowered their stow threshold from the typical 16 meters per second to 14, 12, even 10,
Yeah.
we actually went the opposite way, and our stow with the rigid trackers is 22 meters per second.
So you get much better yield in the high wind environment.
Right. So when everybody is stowing the tracker,
Yeah.
I'm still tracking the sun.
And people think stowing, oh, well, it just goes and parks for a little while, but actually takes a long time to get there.
It takes a long time to get there. Since you stow at a steep tilt,
Yep.
if you catch the sun on the wrong side, you don't produce anything.
40 minutes to get back, yeah.
Right. So by winds or high wind speeds are typically correlated with overcast skies, where diffuse light is actually the light that you are collecting. And for diffuse lights, the best way to collect it is when you stay flat and you see the whole sky.
Yes.
If you're just facing half of the sky, you're losing a whole lot of diffuse energy as well.
That was quite a revelation to me too, because I just imagined the trackers would follow right to the end of the day, but they actually do a bit of backtracking. And is that because of that incidental, non-direct light?
So the backtracking is specifically to avoid shading. Trackers are one after the other.
Yes.
So if you actually tilt, when the sun is like coming up the horizon, right?
Yes.
If you tilt
Long
the tracker,
shadows.
right, you have very long shadows. So you would shadow the neighbor and the neighbor and the neighbor.
Yes.
So we actually backtrack.
Yes.
So we do not cast shadows, and then once the sun gets high enough, we actually get back onto the optimum angle.
Yes. So you're always thinking about maximum yield under any conditions by adjusting all sorts of parameters, whether it's stow speed, backtracking. One of the questions I get from companies who say, is it worth putting in a tracking system, is what's the advantage over, say, a fixed array?
Right. So historically, people used to say, oh, trackers make sense in high DNI places. If we still remember, we have like global irradiation. Global irradiation is divided in diffuse and direct. Direct is the one that comes from the solar disk. And they say, oh, if I can track the sun, means that I'm pointing to the sun at all times. It's very profitable to me if I have a lot of direct light. If I have lots of diffuse, not really. That were the times where the difference in cost between a tracker and a fixed structure was very, high. Today, that's not the case. And I can tell you that we are doing projects in very high latitudes. For instance, you would not think that, very northern countries like Lithuania, Sweden, Denmark would use trackers. Well, they ran all the yield calculations, all the LCOE, and it makes sense to put trackers even there.
It's like 60 degrees latitude.
Yeah, it's almost in the 56 or something.
Yeah,
after
right.
65, it's the Arctic Pole, right?
That's all right.
Or the, so, but even at 56, 57, trackers are making sense when you run the numbers. It's very tight to the module cost as well. It
Yes.
fluctuates a little bit, but like I said, we've been going up and up in latitude, and trackers are making sense more and more in more and more locations. That's what I want to say.
What about the advent of bifacial modules and tracking? How does that work?
Right. So tracking allows to collect the direct lights better, of course, or more, and then it also has, like, if you want a clear back surface or more. How should I say this? Like not as crowded of a back surface like a fixed tilt, because the fixed tilt you have a bunch of steel components underneath, right?
Yeah.
So it's you're not getting almost anything from backtracking if you put the bifacial modules on fixed tilt. So tracker helps with that, and then you can play with layout variables like pitch, like height above ground.
Yes.
There are certain strategies to maximize albedo, and moving all those knobs, you can actually find the best combination to, make your overall energy production the highest.
I know at my place I have a 2P tracker and a 1P tracker, and they're split half and half, bifacial and monofacial, and I get about 8% more from the bifacial.
You really?
Yeah.
Very nice.
Particularly the 2P tracker, because it's higher.
Got it.
And it'll get more albedo, even just off grass.
But let me understand. So you have like half and half on both trackers?
Half and half on both trackers. So
Understood.
it's a perfect comparison.
Oh, very
Everything
nice.
else is the same.
Oh,
Yeah. It was a
I'll be
partnership.
down to go visit you.
You were welcome.
Yes.
Yeah, yeah.
Yeah.
Well, it's been great talking to you,
Yeah,
Pedro.
likewise.
Yeah.
Thank you very much for the opportunity.
Okay.
Okay. Take care.
Thanks.
Thanks.